Now, before we move forward and start to talk about neural networks, do we have any questions?
Can you explain the pixel density things at the very beginning? I I'm just not sure how you plot it. Like, so we have X pixel one in the X, we have pixel two for the Y, but it seems like it's just a categorical variable. How is like getting more further away in the pixel one axis mean?
You mean like this plot over here on the left?
Yes, like
Okay.
yeah, we have pixel one and pixel two, and you say that the plus and minus might coming from different images. Um, but what is the coming from different image of pixel one, pixel two mean? Is that just means the same location?
Yeah, so you will have like different pixels in your images, right?
For one
So
image?
let's say your image is 30 cross 30. So it
Uh-huh.
will have roughly 900 pixels, then the space will be like 900 dimensional long. So right now I'm just showing like 2 dimensions because I can't plot like 900 dimensions, right? So let's say your images only has 2 pixels,
Mm-hmm.
right? Then you can just plot like on this coordinate, right?
Oh, okay. So the pixel one, pixel two means the x-axis and y-axis of the resolution.
No, no, no. Okay. So let's assume your images have only 2 pixels, right? We can generalize it to 1,000 pixels as well. Okay.
Mm-hmm.
Now, and let's say it's grayscale. Again, we can generalize it to RGB images. We'll just have to extend like dimensions. Okay. So it's a grayscale image with just 2 pixels, and pixel one, whatever intensity you have in pixel one, it's the x-axis.
Okay.
And whatever intensity you have in the second pixel, it's the y-axis,
Okay.
right? So you take like one sample and you saw that, okay, it was like pixel 2 has this amount of intensity and pixel 1 has this much, so you just plot it. So this is your first sample.
Oh,
Let's say
okay.
this is motorbike, and again you have another image which is like this. I mean, this is just giving you the pixel intensity of pixel 1 and pixel 2.
Okay.
And similarly you can do for a lot of samples, and essentially what will happen is you won't get like any grouping because, as we discussed, the intensity of pixels may vary due to a lot of factors, right? So what might happen is if you have like, let's say, very bright images, one is from motorbike and let's say one is from something else, let's say car. And if they're very bright images, they might be like in same set of category, even though like they are different objects. But if we have two images which are, let's say, in a very dark condition, let's say very low lighting, even though
Mm-hmm.
they are different objects, then they will might fall in like the same category, right? So pixel values doesn't define the objects.
Okay. So it's the same way for the header and wheels, handlebars and the wheels. We just like, okay, this is the image one. We take a look on the handlebars. Yes, it has a pretty high density. Then we just plot the green, plot the negative. And then we look at the same picture. We look at the wheels. Yeah, it has a pretty high intensity. We plot another negative, but then we look at another image. Um, it has way higher intensity for the handlebars. We plot the plus.
Yeah.
Okay, got it.
Mhm.
Mhm.
Okay, any other question we have? All right, good. So let's move on to the next segment. Now, any questions? Okay, question from Rudy. Is bias added along with the first layer output for the second layers? input. So bias is not added. You just add like one extra parameter there, and you hard code that as number one, and that's it. That's just increasing the dimension of your input. And what will happen is you add the bias in your weights. Okay, so for each layer, so for each perceptron in your network, you will have a bias. And you know that each perceptron is actually represented by number of weights, right? So that bias will be used along with those weights.
Can you explain what BIOS is stand for? Because I feel like if we try to train a model that we are more interested in its weight, then we have to like hard code the BIOS for every perceptron? Then I just feel like it's quite inefficient.
No, why it's inefficient? It's just one bias per neuron, right? And it's just kind of a, you can say like a value adjustment, right? If you want your values to be in certain range, then that bias will be learned like that.
Oh, so you add a bias because you want to like control the range of the certain value?
Right, right.
Okay, I
That
see.
that's one of the motivation. Of course, there are like a lot of other explanations to that, but that's like one
Okay.
major tuition.
So it's something like the computation result is like too small, then we can add a bias to kind of like enlarge it a little bit to make the what was that to make the decision a little bit better because the value is slightly larger. It's
Mm,
more
yeah,
meaning.
yeah.
Okay. Uh, will we have a beneficial effect if for the first layer if the first layer perception is more than the input? Like for example, we have 1, 2, 3, 4, 5, and we have 5 input. Now we are trying to compute with 3 perception for layer one. But what if we have like 7 perceptions for the first layer?
Yeah, that's a very good question, and we'll touch upon that, like how many neurons you should have, and more specifically when we talk about CNNs, like how many kernels you have. But that's a very good question, and to be frank, like it depends upon what problem you are solving. Okay, so that's a very important factor,
Okay.
and you don't want like too many neurons in the first layer. So that's another like you can say like maybe some kind of rule. And another factor which determines like how many neurons you can have is the dimensionality of your input data. If it's too high, then having too many neurons in the first layer, then the number of weights will just blow up, right? It's like multiplicative.
Okay.
So the dimensionality of input also controls like how many neurons you can have.
Okay. So
But again,
basically,
that's a design choice, and I mean there is no hard rule like how many you should have. Okay.
okay. Just use feeling.
Sorry, say that again.
Just use your feeling to decide.
Yeah. And this is just one parameter. I mean, later in the course, you will see like there are a lot of other things which makes this like very, very complicated. And of course, when you do your programming assignment, then you will figure out like a lot of other things as well.
Okay.
But yeah, that's a good question, and we will touch upon this like several times in the course.
No problem. I'm looking
Okay, so another question from Giacomo: if neurons will be learned from training data, how is bias value calculated? Bias is also learned. So bias is something, I mean, it's again a parameter, right? So if you look back right over here, right? It's with the weights. So it's also a parameter of your network. It is also learned. The only difference between your bias and weights is bias is not affected by the input, right? And that's why it's like kind of, you can say, I mean, like if you want to keep your values into certain range, then it doesn't matter like what your input is. It will try to control that. Okay, so bias is something which is independent of your data. So if you think of like the general term bias, right, as a grammatical, like what's the meaning of bias? Bias is something as a human, when we make some decisions, we have our own biases. We assume things, right? So that bias is something, irrespective of what the situation is, we will be inclined towards that direction. Okay, and different people have different biases. So let me think of a very concrete example here. So let's say if I have a bias that, okay, let me pick an animal which I should not talk about cat and dogs. Uh, let's talk about rabbits. I mean, I know you might have a rabbit as pet, but don't take this personally. So, or let's talk about fox. I don't think you will have fox as a pet. So, if I have a bias that fox are very loving animals, so that's my bias. So, in any situation, if I encounter a fox, then how I behave, that behavior will be biased based on that bias which I had earlier, right? If I think like they are loving, then I will go close. But another person who has a bias like, okay, fox are very dangerous, then that person will run away. So that's the intuition, right? So depending upon bias, the decision will change. So these biases are actually playing the same role here. Okay, I hope that's clear. So, all right. So any other question before we move forward? I think we are almost done. I think we will cover the lecture next time, but we do have a pop quiz for you. So I will explain the question here, then you can go to web courses and I will just release that assignment. You will have roughly 1 minute to submit it. Okay, and there I think will be just one chance, as I discussed earlier. So the question is, let's say you are going to design a neural network where your input data has 100 different values. So this is the dimensionality of your input. And in this network, you have a hidden layer where you have 100 neurons. And again, this is also the input layer. You can say the first layer. Okay. And then you have a 100-way classifier, which means you have 100 classes in your data set. So basically you have two different layers. The first layer has 100 neurons. Then you have another layer, which is the output layer. It has 1,000 neurons because you have to make 1,000 predictions. The question is, how many network parameters will be present in such a network? And don't forget, like, you have to include the bias as well. So for each neuron, you will have a bias. Okay, so let me, that was not good. Okay, so let me quickly go. You can go to your web courses and let me release this. All right, so it's released and you can quickly submit this. So I think it's almost over. I'm just marking it here. Any submission after this point will not be considered because we are going to go through the solution. We'll use this time. Okay. So let's go to, so let's try to understand this. Now you will have 100 different values, right, as input data. Then if you have 100 neurons in your first layer, then roughly like how many parameters you need, like how many weights you will have. So for each neuron, you will need 100 different weights, right? Because you have 100 different values. So you'll have to linearly combine all those values to get activation for that neuron. And you have 100 such neurons. So that will be roughly like 100 times 100. And if you add one neuron as well, so it becomes 101. So you just multiply 101 with 100. So that many weights you will need. Now the output of this layer will give you 100 different values because these are 100 neurons, right? Each neuron will have activation. Now for this layer, which means you will have 100 different input. So again, you can just multiply 100 times 100. You will need that many weights. And if you add a bias, that will again becomes 101 times 100. Okay, then you just add those two numbers. So this is like number of parameters you have in the first layer. This is number of parameters in the second layer. Just add those up. You roughly have like 20,200 parameters. Okay, I hope like all of you did mark this correctly. Now let's end the lecture here. If you have any questions, I will take like few before we end. Otherwise, let's stop here for today. Okay, thank you.